reaction is when two or more elements or compounds combine to form a single product. So in synthesis, you'll always have just one product. The 5 rules that you need to know backwards and forwards are the following. When a metal combines with a nonmetal, it's going to make a binary salt. In other words, they're going to go together based on their charges. Lithium, we know, has a +1 charge. And nitrogen has a -3 charge in a compound. So that goes together, Li3N. You could then go back and balance it and say that we only have 2 nitrogens. We have 1, so we need 2. And so we need a 6 in front of lithium. The next one, metal oxides and water form metal hydroxides, or bases. We have a metal and oxygen, or metal oxide, and water. We know it can't be double replacement because if sodium went with oxygen and hydrogen went with oxygen, we would have the same thing that we already have. So then you have to think, oh, that's the synthesis rule, metal hydroxide. My metal is a +1, hydroxide's a -1, so it's NaOH. Again, we need a balance, so we need a 2 in front. On your homework, you do not have to balance the reaction prediction until we've checked them in class. For number 3, non-metallic oxides and water form acids. So again, we have a non-metal oxide and water, so it's going to make an acid. We know the acid's going to start with H, and it should be a polyatomic ion that has N and O in it. The oxidation number will remain the same. We'll talk about oxidation numbers at the end of this chapter. So it's either NO2 or NO3. For now, figure out which one balances it. If I use NO3, then that's 6 oxygens, and cutting it in half, that will work. If I used NO2, then it wouldn't balance out. Metal oxides and carbon dioxide form metal carbonates. So they're combining to make CO3. So I got my metal and I got carbonate. They go together, K2CO3. And that one's already balanced. And the last one, metal oxides and non-metal oxides form salts. In other words, it's going to form a metal polyatomic ion. Our metal in this case is calcium. And our polyatomic ion is either going to be SO3 or SO4. But I need that oxygen to come over so it balances. So it's going to be SO4. Those charges cancel, so it's just CaSO4. Decomposition reactions occur when a single reactant is broken down into 2 or more products. You know it's going to be decomp because you're only going to start with one thing. Notice all these have one reactant. So the 5 or 6 rules that you need to know for these, again, backwards or forwards, because these you could see backwards for synthesis reactions. Metal chlorates decompose into metal chlorides and oxygen. Well, this is a metal and chlorate, so it should be a metal chloride. My metal was magnesium. Chloride is Cl, so it goes together like so. And oxygen can't stand alone, so it's O2. Balancing it, we get 2, 2, 3. Make sure that you can do it forwards and backwards. And so if you had magnesium chloride and oxygen as the reactants, you'd be making a metal chlorate. So the second one says ammonium carbonate decomposes into ammonium, or ammonia, water, and carbon dioxide. So we have our ammonia, water, and carbon dioxide. And that's already balanced. Well, just a metal carbonate will break down into our metal oxide and carbon dioxide. So our metal oxide. Again, make sure you're always checking those charges. And carbon dioxide. And again, those balance. If you just have a binary compound, as in just two elements, no polyatomic ion, the only thing it can do is break apart into those two elements. But remember that your diatomics can't stand alone. So sodium is by itself, but chlorine is going to be a 2. Hydrogen peroxide gets its own rule. Hydrogen peroxide always breaks down into water and oxygen gas. So balancing that one, you would put a 2 and a 2. And finally, ammonium hydroxide, you should know from our previous lesson, ammonium hydroxide always breaks down into ammonia and water. Combustion reactions, once you recognize them, are the easiest to predict the products for. Remember that a combustion reaction is a simple or a fancy way of saying that we're burning something. So in the presence of excess oxygen, most hydrocarbons and alcohols can undergo complete combustion to produce carbon dioxide and water. When balancing, usually you want to balance the carbon, then the hydrogen, and then finally the oxygen. So for that first one, we have a hydrocarbon. It's made out of carbon and hydrogen. We added oxygen, so we're going to produce carbon dioxide and water. For the second example, it's an alcohol. We have carbon, hydrogen, and oxygen. And we have oxygen as a reactant. So we're going to produce carbon dioxide and water. So sometimes it's just carbon and hydrogen, sometimes it's carbon, hydrogen, and oxygen. But you have to have oxygen by itself as well. Then you can go back and balance those. So at the end of the video, go ahead and balance those two combustion reactions. And finally, single replacement reactions involve an element replacing one part of a compound. An element can only replace an element that is less active than itself. So for the halogens, this list is on the periodic table. Fluorine is the most active. Iodine is the least active. So with single replacement, you have an element and a compound. The element is always trying to replace the element with the same charge as it in the compound. So chlorine is negative, so it wants to try to replace iodine. Chlorine is above iodine, therefore the reaction will take place. Potassium will combine with chlorine. They both have one charges, positive one and negative one, so those cancel. And iodine gets kicked to the curb, but it can't be by itself, so it's I2. The next example, iodine is trying to replace fluorine. Because again, iodine's negative, fluorine's negative. But iodine is below fluorine, so no reaction. Nothing would happen. Most of the time, you're going to have a metal trying to replace a less active metal, or hydrogen. So only metals from lithium to sodium will replace hydrogen in water. From hydrogen up, we'll replace it in an acid. So when you're doing single replacement reactions and you have water, you have to think of water as HOH, because the metal will only replace the first hydrogen. So in this first example, iron is trying to kick out hydrogen in water. Iron is above hydrogen on the list, but it's not one of these first ones. And it says only lithium to sodium will replace hydrogen in water. So no reaction. Sodium, when it tries to kick out hydrogen though, Sodium is one of those first 5. And so sodium combines with hydroxide and kicks hydrogen to the curb. Hydrogen can't be alone though, so there needs to be a 2 in front. For the next one, magnesium is positive, so it's trying to kick out positive iron. So looking at the list, we got magnesium and we have iron. Magnesium is above iron, so it can kick it out. So iron gets kicked to the curb, and magnesium combines with chlorine. But remember, make sure you're checking those charges because it should just be MgCl2, not MgCl3. And finally, the last one, aluminum's positive, silver's positive. So aluminum tries to kick out silver. Silver's way on the bottom, so it does kick it out. So silver's kicked to the curb, and aluminum combines with nitrate. Again, aluminum is a +3, nitrate's a -1, so it goes together in the following formula. I'm going to pause the video and figure out if these are synthesis, decomp, single replacement, double replacement, or combustion. Restart when you figured that piece out. So this first one, we have 2 compounds, and neither of the compounds are oxides, so this one's going to be double replacement. The next one, we also have 2 compounds, neither oxides, so double replacement. The next one, we just have 2 elements, so that's going to be synthesis. And the last one, we have 2 compounds, but one's an oxide in water, so it's going to be synthesis as well. We're going to pause the video again and write your reactants formulas. So like sodium, hydrogen carbonate, plus HCl, yields, and then predict your products. Restart when you have the complete reactions done. All right, for that first one, it was double replacement, so you should have got an NaCl and H2CO3. Now remember from our lesson the other day, we said that HCO3 doesn't exist and it breaks down into water and CO2. And that equation is balanced. The next one, you should have gotten that for your reactants. And that for your products. And that equation needs a 2 to balance it. So aluminum and fluorine should have been Al plus F2 because fluorine's diatomic. It's synthesis, and aluminum and fluorine go together like so. And the last one, it's a synthesis reaction. So we have a metal oxide and water should make a metal hydroxide. And that equation is balanced. So I'm going to do the practice that was assigned.